Okay, in the previous video, we looked at how to create a Taylor series using the first several terms and coming up with the general pattern. What we're going to look at now is some examples of how we can use a known Taylor series to transform and create a new one. So, for example, we want to find the Maclaurin series for f of x equals the sine of x squared. Well, I could start from scratch, or we could use the fact that we already know the Maclaurin series for sine of x. This is what we came up with in the first example that we did, okay? So we've already derived that one. And if that is one that we already know, then if g of x is equal to the sine of x, then that means that sine of x squared, which is what we want to find, is equal to g of x squared, which means that all I need to do then is replace every x that I have with an x squared. So using this series, we would have our first term would be x squared minus this next one is going to be x squared cubed over 3 factorial plus x squared to the 5th over 5 factorial minus x squared to the 7th over 7 factorial plus ... Okay, and so we can simplify that out and we get x squared minus x to the 6th over 3 factorial plus x to the 10th over 5 factorial minus x to the 14th over 7 factorial plus ... Now, we can go ahead then and determine our general term by trying to figure out this pattern. So we already know from before that we have an alternating term. That hasn't changed, -1 to the n. And we know that the denominator didn't change, so that's going to be 2n plus 1 factorial. We need a plus right here. The problem is we have to figure out now how to get 2, 6, 10, 14. So there is going to be a lot of practice with finding number patterns here. And hopefully what you notice is that's just double whatever the denominator was. So it's going to be 2 times 2n plus 1 is what we're getting for the exponent. So if you think about that, 2 times 2n plus 1 means that that's going to come out to be 4n plus 2 would be the power that we want. So that's going to be our power of x. X is going to be to the 4n plus 2 power. So let's go ahead and check that. For our first term, n equals 0, we get x squared. For our second term, n equals 1, 4 times 1 plus 2 is 6. If n equals 2, 4 times 2 is 8, plus 2 is 10. So that does seem like it works. We could go on from there and use that general term to find our radius and interval of convergence if they ask. But the main thing here is that you can use function composition to take a function you already know and create a new one, okay? And so what that allows us to do is that we can use a basic list of known power series, okay? And then we can use them to build new power series. Now, the AP exam, which none of this is being tested this particular year, 2020, because of the COVID-19 pandemic. This will be a fun little reminder if we watch this video in future years. But what we are suggested to know by memory is e to the x, sine of x, cosine of x, and 1 over 1 plus x. Those are the 4 that are expected that you have memorized when you take the AP exam. But obviously you don't have to memorize any of that today, so you may as well use this list to help you out. Now, we've seen some of these already. In the previous sections, we derived some of these on our own. This first one 1 over 1 plus x, you can use the geometric series rule to figure that out. We've done natural log of x, we've done e to the x. So this is just kind of a summary of all the ones that we have found so far and some that we haven't. But now you can go ahead and use this information here. Okay. So let's look at one more example like this. So the binomial series expansion is, here's a couple of side notes about that. We're not going to use that one very often, but again, it's there for your reference. So what we want to do is we want to find the power series for f of x equals cosine of x squared, square root of x. So what you need to do is use the series that is up above for cosine, and instead of using x, we want to use x to the 1/2 as our power. So I would like for you to go ahead and pause the video and try this one on your own now that you know what to do. And I'm going to bring the answer to you in 3 seconds. This is what you should get. Now, I went ahead and found the general term there because if you want to find the radius of convergence or the interval of convergence, you do have to have that general term. So I went ahead and found it, even though they didn't ask us to do that. But so that is how you can use known power series to use some function composition and come up with a new power series. So that is another strategy that you can use.